Sure, this is final project from natural language processing course, and this is the final project. And in our final project group we have two members, first me, Dauletkhan Zhambyl, and then Rakhatuly Imangali. Firstly, I'm going to explain my part of the project. We choose the sarcasm, not sarcasm, determining project. And then I'm gonna explain my part firstly. So we importing all the needed libraries firstly. Then we are reading the sarcasm headlines dataset JSON file here, first 5 rows. And then in the article link, we choosing only needed information using regular expression, and then creating source column with this information. Then we are dropping the article link. Then we are converting headline to lowercase, and then removing this pattern using regular expression, replacing with this empty string. Also, we're removing this pattern, replacing to empty string from the headline. Then we are creating a dictionary named contractions dict, containing English contractions as case and their expanded forms as values. Here we can see the k and then the value, the k and then the value. So then a regular expression pattern is compiled using the recompile function. This pattern matches any of the contractions in the contractions dict. Then defining expand contractions function, which takes a text input and expands any contractions found in the text using the contractions dict. It uses function replace to replace each matched contraction with its expanded form. Then using the expand contraction function to the headline here, expand contractions. Then two new columns were created. They are char count and then word count. The char count contains the characters. Char count contains the characters for each headline. Likewise, the word count contains the count of words in the each headline. Now we're showing 10 rows, and here we're creating a histogram. Here we created a histogram plot to visualize the distribution of sentence lengths used on the word count in df, in data frame df. Here we created a histogram to visualize the distribution of sentence lengths in the headlines with differentiation between sarcastic and non-sarcastic. Sarcastic headlines, it provides insights into how sentence lengths varies between sarcastic and non-sarcastic headlines in the dataset. Here we're creating this histogram to visualize the distribution of sarcastic and non-sarcastic labels in the data frame, providing insights into the balance or distribution of these labels in the dataset. We're creating the similar histogram. This histogram is to visualize the distribution of different data sources in the data frame df, providing insights into the distribution of articles from various sources in the dataset. Then we are creating function get top n words. It takes as input a list of text and then the number of top words n to return, and then the value of I for the n-gram range. So we're firstly initializing the count vectorizer and then transforming text to bag of words, then summing words occurrences, then creating word frequency pairs, then sorting by frequency, then returning the top n words. Here we're words get top n words def headline 20 and 2 calls the get top n words function with a headline column of the data frame def, requesting the top 20 bigrams, as here we have n is 20, and then bigram is going to be bigram because I is 2. Then we are creating the data frame bi creates from the list of top bigrams and their frequencies. It specifies column name is bigram and frequency for clarity. Then we're showing the new data frame. Here we're creating a histogram. This histogram creates a horizontal bar plate to visualize the frequencies of the top bigram extracted from the headlines. The length of each bar represents the frequency of the corresponding bigram, providing insights into the most common pairs of words in the dataset. Now we're importing word cloud. Then initialize a set of stop words from the stop word set provided by the word cloud library. And then this line adds additional custom stop words to the set. They are want, first, will, want, and give. These are words that are common or uninformative and are excluded from the word cloud. Then we're combining headlines. This line concatenates all headlines in the data frame def into a single string named text. Then we are printing such words in combination of headlines. Here there are such words in the combination of headlines. And then creating and generating a word cloud image. It takes word cloud takes various parameters. Firstly, max font size 50. This sets the maximum font size for words in the cloud. Max word 100 specifies the maximum number of words to be displayed in the cloud. Stop words specify the set of stop words to be excluded from the word cloud. And then background color white, it sets the background color of the word cloud to white. And then generate text generates the word cloud based on the combined headlines text. Then we're displaying the generated image, displaying the word cloud. Now, firstly, this line creates a new figure with a specified size 10 inches and then 8 inches. 10 inch is width and 8 is height. Then this function displays the word cloud image, and then PLT axis off turns off the axis for better visualization, and then PLT show displays the word cloud plot. Then we are save the image in the image folder. So here's our word cloud.
I'm going to explain you the functional part of our NLP sarcasm detection final project. So we have our packages like BERT tokenizer, the torch, Atom, the NN for a neural network, and we start with setting our tokenizer. We're using pre-trained BERT Tiny, um, and then we have our custom dataset class, which has the labels, which is our labels, which is numpy array of y. Y is set to is sarcastic column, which is one or zero. So, and we have a text. We tokenize the text with the padding of max length, which is 512, and then uh, this returns the label. This returns the number of labels we have. The get batch labels returns the array numpy array with the labels with the corresponding index, and same with the batch text. The get item uses these batch label and batch text get functions to return the batch text and y labels with the corresponding index that we are given. And we have a bird classifier class, our neural network. We first use BERT, or a pre-trained model, and second we have a dropout layer, which is uh, our dropout rate is 0.5. The linear layer, which returns our output, which gives us two outputs, and the final layer is ReLU. And then we have a forward function. It assigns our BERT to a pulled output, and we send this pulled output to dropout, and the dropout output we send to linear, and the linear output we send to ReLU, and we return the final layer. So we have then the def function, or train function, which gets the model, our x and y, the learning rate, epoch number, and the batch size. We first send our x and y to the dataset. We assign it to the train, and then we create a data loader with a given batch size, and we are setting the shuffle to true so that the value inside is shuffled. The use coda is used for it sets the device that we are using to GPU if it is available. We have a criterion which is cross entropy loss and optimizer as Atom. So this if checks if we have the GPU available, and the main function starts here, or the train. We first iterate through the number of epochs we have. So then we this sends the train label to our device that we are using. That's the appropriate device that we are currently using. It's either GPU or uh, this, or I don't know what it is. Okay, then we have our attention mask and the input indexes. We set them to the model, and we assign it to the model we output, and then by using criterion and the train label, we get our the batch loss, and we each time we add all the losses to a total loss train, and uh, by doing this we can calculate the accuracy, and we also assign it to the total acc each time, adding it to the total accuracy train, and then we zero grad the model and do the backward, and then we optimize it, and we print each time the epoch with the total loss and total accuracy that we get. And then we have the evaluate function. Same here, we send the x and y to the dataset, and then we create a data model with a batch size, but this time the shuffle is false because it is a prediction set. We don't need to shuffle them. Then use coda the same. It just sets our device to GPU if it's available, because uh, we don't we don't want our CPU to work that hard, and we have the set the test labels that are attention in the input ID indexes, and we send it to the model, and then we get the output, and then we append it to the our prediction. So, and this is where we assign our x and y and split our datasets. X is the headline and y is the sarcastic, which was um, in our projects here. We had this dataset. So I set the epoch number to 5, the batch size to 32. The model is this bird classifier, and then the learning rate is this is essentially 0.0001. Then we trained our model with these initial values. This is our 5 epochs with the loss and accuracy, and we evaluate our prediction, and then we concatenate all of them by using torch cat, and then we use numpy to make an array. So then we use the classification report to have our precision recall f1 and accuracy set here. So as you can see, the model has 85+% of chance getting our sarcasm